Okay, in this tool, I want to demonstrate um, awesome, just absolutely awesome tool, superscan. Now, I like to keep handy a folder on my desktop, tools that just run. So I've conveniently named it so, and I have all sorts of things in here. And so today we're going to play with superscan. Superscan is a great uh, scanning tool. In other words, it's easy to use. It comes in a GUI interface. It's very, very simple. You just put in the information and you get an output. You really just can't go wrong here. So the IP address that we're going to target that we've done from our reconnaissance earlier is 192.168.92.131. And you can go ahead and put in the IP address. Don't forget to add it in here. Notice it conveniently fills in the starting IP address and the ending IP address. And then we could change that. So I'd always start with the IP address, let it auto fill out the fields, and then just change the numbers accordingly rather than typing all of this out. So we're just going to go ahead and hit scan here. Now our target happens to be a Windows 2000 server, which I specifically keep on hand just for the sake of demonstrating, completely vulnerable systems. It's not patched. It's never been patched. So the information that you're learning about your target here, you want to read basically as a book as you get these reports. Now, superscan just takes a couple minutes to run. Sometimes it depends on how many hosts you do versus a single target. But once you get it done, just go ahead and start at the top and basically read it as a book. All right, so live host in this batch, specific one, we know that because we put in the specific IP address. It tells us this, and it tells us the open ports. Now, this is where either by memory, simply because you've looked it up already, you would actually know the port and the protocol associated with this, or if, let's say, it's something that you've never heard of, okay? For example, 636. Typically an unconventional port to see that open specifically in a server, unless you're looking for secure LDAP, as opposed to some of the common ones like 443 and 88 and 80, 53, 21. Those are a little bit more out of run of the mill, should you say. Also found a handful of UDP ports. So this is where I basically just come in here, copy all of this, right click, copy that, and use that for my reporting. Now, this specifically is, just one live host, but it gives a nice little high-level summary, which is what you can go off of to just kind of get a basic map of how the operating system responds in the network. And down here, you can basically do the same thing, right? A little bit of a summary. So service, TCP ports, and UDP ports, the packet delay within the scan, the different discovery phases. If ICMP pinging is also going after the host, so in other words, that's part of one of the protocols that goes back in the exchange. And if you really want to treat yourself here, go ahead and sniff this traffic and see what the scan looks like from the other side. So not just from the end user side, but also, what would a man in the middle see on the network? What better way to learn and to actually read and study the output of Wireshark, either on the client or the server. Okay. But moving right along, all right, host names that were resolved, a full Connect TCP scanning service, different timeout values for TCP and UDP, host name lookup, if it can resolve the host name, and any sort of banner grabbing. So host name lookup, maybe there's a naming convention that we could use as opposed to just some random bunch of numbers or letters. Actually look for naming conventions like server 1 or server 3 or server 5, or if there's server 10, that tells me there's probably, at least over time, been at least 10 of them. Whether they're fully operational, now I could go look, right? So just being inquisitive goes a long way. So the scan of the host started, the scanning machines, some basic stuff here. ICMP, echo, you can see this when you sniff it. You can see the ICMP, so that's something I would look for. And also SYN request passed for the different ports that it identified. The different types of banner grabbing, SSL, TCP, and UDP, and the time that it completed. Again, I just copy all of that, right-click, and basically save it to a file or just view the HTML. And that's a basic overview of, let's use a freeware tool by Foundstone and McAfee to just do some basic poking around on the network. All right. Now, I want to walk through the other parts of the menu, the menus here as well. Okay, so when it comes to specific host discovery, you can set a handful of values. I typically don't change these. I mean, echo request, you can see this. If you really want to get intimate here with the options, set each option and then sniff the traffic and then look for the anomaly. And if you can do that, you definitely are a protocol analyst. UDP port scan if you want to name specific or common UDP ports or a specific range. TCP ports, again, starting and ending, or the specific one. Now, there's already a handful of good options here to start with. You don't need to run all 65,000 ports. But if you really, really wanted to the first time through, just to get a very, very, very thorough thumbprint of your target and then move forward with complete and accurate data, and you have the time to do that, well, I highly recommend it. The different types of scanning options, host discovery passes and service discovery passes. This also will determine how much time the actual scan takes. Here's the option for host name. You might have seen this in the report. Here's the option for banner grabbing. You also saw this in the report. So there's direct correlation between what you select back here versus what you see in the front end report. The different tools that it wants to or can use. Okay. Now, this is fun because if you just know what you're looking for here, you can absolutely just get some good information here. So a good example here would be, www.cybrary.it. Right, and we can reach out to Network Solutions, and we can go ahead and just do a host name or IP address lookup, and it'll go out and try it. And then it may take just a little bit for it to run, but nonetheless, you can just selectively choose. Like if you want to see, you can do a zone transfer, okay, or the HTTP head and GET request. This can reveal the specific types of servers that it's on. So in this case, we're able to see that it's an Nginx server. In the grand scheme of things, that's not as popular of a server as opposed to something like Windows, or by far the most popular web server is Apache. Okay. Also, the specific HTML code, I would recognize these pieces here as HTML code. And when you do web application pen testing later, you'll look for this convention, okay, because this is actually the HTTP information that goes back and forth, okay. You can do who is information, okay. You can pull all of that. You can do ARIN. You can do an ICMP trace route from you to your destination. And again, document all of this and then read it like a book. In the world of penetration testing, it's all about, how do you read the tea leaves per se. Okay, so it's always, what picture gets painted. Allow the evidence to do the talking, or allow the numbers and the letters and the names and the conventions do the talking for you. And it slowly starts to get you building a map. All right, so after I would do some basic tools here, then I would actually look at enumeration. For enumeration, I'm going to evaluate my target host 192.168.92.131 and go ahead and select enumerate. And definitely the first time you go through this, leave all of these checked and then go back all the way, and you'll get a very, very lengthy report. And I'll show you where you can spend your time here and when you can typically skip or browse over stuff. Okay, so we wanted to see if we could speak NetBIOS to the target, and we did. We got NetBIOS address resolution here. So I have the actual name of the server, the domain that the server's in, the administrator, which is unique service. That's a messenger name, so that might be worth targeting in terms of spending your time. The INET services. And then the workstation services. On an old computer system like Windows 2000, these are easily exploitable. That's one of the fun parts of using an older operating system, is because, the older it gets, the more fun it gets. Tells us our MAC address. We probably could have done that in a variety of ways. It just conveniently tells us here, which is the value of using a combination tool like this. Null session connections, 192.168. 92.131, okay, and it also connected to the IPC $. Some layer 2 information. In other words, it's binding to protocol TCP/IP, and that would make sense considering we put in an IP address here, so not really a big help. Windows 2000, it guesses the operating system. the platform and the specific version. You would use this information if you were going to research vulnerabilities related to this particular build, the different services that it has running on it, and different user accounts. So in this case, we got a lot of information, okay? Because if I can pull from the network the administrator that it's a built-in account, well, that saves me a lot of time later if I'm going to try to brute force the password file. The last login, when the password expired, when the password's changed, so the fact that it's never been changed, or 1539, I specifically don't change it at this point just because I want to see how high I can get the number. So 1539, that's every day is a new record. If lockout is disabled, this is important because if I'm going to try to brute force the account, I don't want the account to get locked out in the process. The number of logons, which is in this case very, very high. Normally the number of logons is much, much less. So I want to point out the anomaly here. If you're reading this for the first time, it's quite significant. Very rarely, the reason why it's high is because this is a standalone VMware workstation build. It's not on a production network. If this was a production network, I would expect the number to be higher. But in this case, for a standalone system, that's pretty suspicious. And then it goes through and names the guest accounts and subsequent accounts. And if you were following along in this list over here, we're right around the user section. So in this case, it has quite a bit of users, and these are all users that I've preloaded in over the years. Actually had these uploaded with a script. I promise you I did not sit here and create 180 user accounts. So you want to be smart wherever you can. But let's jump down to the group section. Okay, the different groups. So this is helpful. I would definitely look for the naming convention. Specifically, I see group X that is actually from an exploit utility called x.exe. So that's there. Or, HAXOR versus specific names. Okay. And then these lists can get quite large as well. The different groups, remote procedure call endpoints. And, until you're starting to evaluate specific protocols like RPC, and unless you're looking for that specific vulnerability, I would basically scroll down and skip this. But if it was specific vulnerability related, then you may be able to find some references here that you can use. But that's out of the scope of this tool. The password and the account policies, this is always nice because in this case we have a maximum password age of 42 days, which is on the longer side. The minimum password length is 0, so you would expect a minimum at least 8 characters on any sort of STIG that has or machine that has a STIG applied to it, or a guideline that has been implemented against that machine for hardening purposes. The different shares, so I might want to reach out to these things across the network and simply start trying to map drives or do null sessions to the shares. Okay, the domain controller information, and of course the date and timestamp, and then some logon information here. It tells us our uptime or idle time, the different drives connected to it, the trusted domains. So in this case, it's a single domain. There's single forest or single domain in a single forest, but this would reflect the forest information or domain information. Okay, any sort of remote services, and this is where things get exciting, because if I can find a specific service that is up and running, that means it's willing to speak that language, for lack of better words. So I can target that specifically for exploits. All right, so it doesn't matter if it's distributed file system exploit or a DNS server exploit. I now need that service running if I'm going to actually get a specific match on one of these. So I'm always trying to match this whole list versus what are the exploits. And the cool part is about Metasploit would actually do this for you. It would try to enumerate all the possibilities of what you could exploit. If it can pull a remote registry, sometimes you can pull a remote registry from your target, but you would want to get access to the system and then copy it that way, if at all possible, because nothing more says that you rooted a system other than having a backup copy of the registry. Okay, and lastly, the About tab, if you wanted to know. This is a McAfee tool now, so superscan has been around for quite some time. So always check out the vendors of these tools and use them appropriately and responsibly.